All right. Good to be back here. Sorry, took last week off. Had family in town, things like that. So I was like, had some other things I needed to work on. But this week I'm back and at it, and we're just gonna pick up where we left off. So we'll just wait around for a little bit. And oh, hey, how's it going, Julio? Just saw you in the Fantasyland getter. You get around, sir. All right. Uh, so just to get caught up, last time we were playing with our random number generator. That was pretty cool. But we decided to take a route to see if we could kind of clean this code up a bit. Let's just take a little gander here. We had this code, which was this Rando error, or arrow, and actually the code we were trying to clean up was this. So we have all this, I don't know, this doesn't look very good. It's very imperative, things like that. Um, so, yeah, we took the route of using an arrow, but that didn't really buy us much other than adding a bunch of complexity and things like that. So what I'm kind of getting at is our intuition that we were using was wrong for coming up with this or how we're approaching this. And I kind of did that on purpose, right? So a lot of the intuition or the way the state is presented in a lot of the JavaScript world, things like that, is it's a way to share mutable state with other functions that depend on that state. And when you think of it that way, you end up with, I don't know, functions like these, right? Just the way that we're thinking about how to implement the state. And if we're knowing that, hey, we just, we share state in these other functions, it makes it real easy to kind of get away from the pattern and start writing a bunch of imperative code like that. So that's kind of when we were looking at the arrow, we kind of saw that it didn't really buy us much. It just added complexity. Like if we look here, we have all these extra lines, and now we're playing with this other arrow type or this profunctor here that we just brought in. And when it came down to it, it didn't really change anything. We still have this imperative bit where we need to split out. So obviously, the way I presented the state is wrong. It's well, not wrong, but it's a very limited intuition that can lead to some pretty ugly code. So to do that, what I want to do on the first part of this is kind of build a new intuition on what a state monad is. And instead of thinking of it as a way to share mutable states between a family of functions, we're going to kind of, and I've been hinting at this here and there, we're going to kind of dig deep and look at it more as a deterministic finite state machine and kind of build that intuition around it. And then once we kind of dig a bit on that, we'll then use what we've found or talked about and see if we can tackle another refactor on this Rando to make it feel a bit less disjoined from the rest of, well, from a normal functional program, right? One of the things that was pretty neat here was we did have this CalcSeed and we separated this value from that, right? Except we did it in a way where we had to do it on this profunctor, and then down here, unwrap and call that profunctor that we built out, right? So we kind of had the right idea here of separating this. It's just where we may have went wrong was whenever we how would you say, kind of approached or thought of state in a way that may be a little misleading, I guess is what we'll do. So I guess the best way to start this off is let's build a state machine using state. And one of the typical examples that you'll see when you're looking at the literature for a finite state machine is a vending machine of some kind. Like, it's a really easy way to a lot of people are familiar with vending machines, how they work, they count money, things like that. It's a real easy machine that you can kind of wrap your brain around of what's going on or what could be going on under the hood of that machine, right? So we're going to kind of build out a vending machine state machine, something to track the money and all that. But before we, or how much money you've deposited and whatnot. But before we get into that, let's kind of dig a little bit more and kind of look at what the state is, okay? So let's jump into here. First, let's create a new branch. We're going to base it off this, and we'll call it ADTs 04. We'll just jump right into it here, and we will yarn start this feller. We'll type it properly, I guess. And let's go into our workbench here, and we're just going to clean all this out, right? So let's talk about state. First thing, let's bring state in. So state, we're going to be using that library crocs. So that comes in from crocs, and we can just pull it right off of this namespace. And now we have state. So if we look here, we see we get a function that is the constructor for state, right? Easy peasy. So state is defined like this, and I've said this, or I've had this a couple times. You have some sort of type that represents the state that's going through your machine. While we're building this, we're going to be working with integers, right? And really specifically, we're going to be working with integers that are multiples of 5. That would define the alphabet that we use for the state machine. But enough about alphabets and things like that, or how would you say valid states that the machine could be in. We're not going to get that deep into it, but basically this is going to be a integer that represents this state, and it just so happens we can describe that as all multiples of 5 including 0. Boom. Okay. Also, it's very important. I just want to note in JavaScript, we can't really fix something to a type. We can, but we're kind of free to change functions and change things like how would you say, we're not strongly typed. So you got to kind of exercise a little bit of discipline here, and all the functions, and you want to make sure that all your state is always the same type no matter what. In languages like, I don't know, in languages like Haskell and things like that, I would actually, when I go to build this state, I would specify what that type is. And I would get back a constructor, a data constructor, ready to take the functorial portion of that, right? But in JavaScript, we don't have those luxuries. So anyway, so this takes a state and then some A. It could be any A, and this is where we're a functor. So we're a functor in A, which means A's type can vary. State we want to keep the same, but we can vary on the right side, I think, we can vary the type. Okay. So here, that's pretty much what defines the state. So it has some sort of state that it takes along with it, and some sort of A, right? Now inside of the state, it actually wraps a function, right? So we have a function that's inside of it that moves from an S and then returns a pair of AS, right? So for us to actually construct this, we're going to need a couple things, right? So we're going to need pair, obviously, because we need to return a pair. So we'll just bring pair in real quick. And that will be here, crocs pair. And I think that's really all we need for that. And now we have everything we need to actually construct something. So let's start constructing a little thing here. So what we want to do is on here, we consider this the integer that's there, right? So we have the 0, and that is our initial state. It doesn't always have to be 0. It could be anything, but right now we're going to always initialize with 0, so we start with no money before they put money into the vending machine. So each one of these are possible transitions that can move from state to state. So if we have, we're going to call this add nickel, what that would do is be a transition that runs from 0 and transitions the state to 5, just putting our state into a 5, right? And if we were to call add nickel again, that would transmit what's the word? That would transition our state to 10. And you notice we could have an add dime here, which is just an add nickel, and that would still get us to the same state. So this is what we're modeling here, right? So let's create this add nickel function. So using this right here, this definition, whenever we construct it, we need to construct it with a function that will take some state. In this case, it's going to be an integer. So let's do add nickel here. So we'll do add nickel, and add nickel is going to be a state of int, and there's this special thing for the value. It's called unit, and actually let's bring that unit in here. See, a lot of times when you're dealing with these states, you don't really care so much about the thing on the right. You mostly care about what happened to the state after a series of transitions. So in most cases, or a lot of times, your actual, that A over here on the right, that's going to end up being this unit, or basically undefined. So arrows would be, hold on, Julio's got a question. So arrows would be actions that take a state and return the new state. So arrows would be, yeah. So are you talking about this right here, this arrow, Julio? It basically will take a state and then return you some value of A, whatever that is, whatever A is to be, and then whatever your modified state is. And that will get you back the new state. So just to see what that looks like, I don't know, in the diagram. Oh, these arrows. So the arrows would be actions that take a state? Yes, exactly, just like the state machine. And you'll see that it turns out to be this Kleiss Liss arrow. You're talking about these arrows here. Yep. So each one of these will take the state in and then transition it to a new state. And we can combine and compose these transitions together because we're using the state monad. Yes. And you'll see there's actually, when we start building this, Julio, you'll see that this is a transition from when we do these transitions. It's actually a chain operation. So every time you see this, we're basically calling chain with a specific function that's going to move the state. Because remember, every time you call chain, that applies the effect of the monad. So forget the whole thing about monoids and the category of endofunctors. If you think of just chain, and like when we're using it with these types of data types, think of it as a way to apply the effect of the type. For these types, right? So if I chain a maybe and I return a nothing, that turns everything into a nothing, right? In this case, if I want to read from the state or write to the state, either way, it's actually, since our functions and all that are around the A over here on the right, every time we chain, or anytime we want to read or write to the state, we need to do that with the chain. So anyway, we'll just do add nickel here. So we have const add nickel, and we want add nickel to give us back a state here, and that's going to take a function that takes an s to a pair, and we're going to say unit, right, and s plus 5. So since we have a state of integer and all of that, so since we have a state of integer, we're going to get that integer in, and then we're going to return. Notice the s is on the right here of the pair. We're going to take whatever that integer is that was passed to us, we're going to add 5 to it. And this part over here, don't worry about that. We'll talk about that in a minute. This is the any computations that are dependent on the state. So you can evaluate certain things with that, right? So right now, we now have a state here that we can work with. And what we'll do is kind of log this out so we can see what it is, right? So when we add it, we see that it's a state that's wrapping a function. Well, if we look over here in Crocs, here we have state. This is the actual state we're using. Notice we have these 3 with functions. We have run with, execute with, and eval with. Anytime in Crocs that you see this with, that means that it's going to take a parameter and then execute whatever whatever's wrapped in the underlying type with the value that you pass it. So anyway, we have 3 ways of actually running this state. We can do execute with, we can do run with, and we can do eval with. So each one of these will get you something different. So let's look first at run with. So here we'll just put in a run with. and we need to pass this the initial state. In our case, it was 0. Remember? We're saying that our initial state was 0. So what this state should get us is a transition from 0 to 5 in our state. Oops. Hold on one moment. Sorry about that. Things are hard when you copy and paste. Okay, so now if you look, we see that when we hit run with, we get back a pair that is a unit. That is this symbol here. That represents a unit. And we get back our 5. So our new state is now 5. And any time that we chain or do anything with this, it's going to have that new state of 5. So the other ones, we have this execute with and eval with. What execute with does is instead of returning the pair of the value and the state, it actually just returns the state, right? So we can go here, delete, and if we do eval with, execute with, duh. So if we do execute with, we get our 5 back, and that is the current state. Now, if we're only interested in the evaluation of this, and like what is this A equal to, then like there's certain times, and we're going to use that a lot whenever we implement this for our stuff. We're going to use this a lot. But what eval is going to get you is whatever is set on the left side of this pair, which is the A of this state. Okay, so this isn't very useful for us though, because this gives us nothing that we can chain with. Like it's not set up as a Kleiss Liss, right? So since we have this state, and all state transitions have to happen inside of a state, then we need to be able to chain on these. So to chain on these, that means that we need to have a Kleiss Liss, right? And that's because, you know, when we chain, that's how we apply the effects. And the effect we want to do here is to update that state. So what we need for a Kleiss Liss, and just to remind you, a Kleiss Liss arrow takes an A of any type and gives you back an M of B. And that's what we have here. What we want to do is take some sort of A and then get back an M of unit, basically. In this case, we don't really care about the thing on the right. We really only care about the state with this. But what this would normally do if we cared about this A, it would give us this A in that position, unwrapped from the state that we're chaining with. Anyway, this is the little Kleiss Liss arrow thing. So in our case, that's what we have is for this add nickel, we want a function that will return the state with the modification on the state, and we don't really care about the value for this, so we're just going to return unit on that. So that's why it matches that type. So now we have to change this to be a function, right? And we see, oops, we have to change it everywhere to be a function. Okay, and let's go ahead and we'll put this on execute so we can look at the state, and we see we get back our 5. But the beauty of this is now we can just do chain on this and just add another nickel. So now we have a state of 10. And if we want to add another nickel, all we have to do is just chain in another add a nickel, and it updates the state. But it updates the state in a lazy fashion. None of these state things happen and none of these updates happen until you call one of the with functions that are provided here. So basically, to look at what we did, we start with the state of 0 and then we call add nickel three times, I'm sorry. So we start with our state of 0 and we go 1, 2, 3. And you notice that gets us back to 15. And that's the result that we have. So all of these chains could be considered if you're thinking about it, they could be considered a state transition. Every time we do this, it transitions the state in one way. So yeah, it is kind of like that we're having the ability to update a mutable state, but that's very specific, or mutable state, I'm sorry, but that's very specific to the implementation. Kind of a more abstract way of thinking of this is like this, is a deterministic finite state machine, with each of your chains being transitions. So one of the things that are horrible, though, is you'll notice to do all of these, we have to build out this state function here, right? Like this is pretty much this right here. If we were to be able to take S and then take whatever that S is and add 5, that's like your normal JavaScript function, right? Like those are the functions that we work with every day. We don't work with these things that lift a pair and put a unit in. Like this just seems ridiculous, right? We don't write functions that way. And if we did, we wouldn't be able to move this to any other type of monad or any other type of type. These functions become very specific to this. In this case, it doesn't matter, but a lot of times in the real world, it does matter. So, stand by here. And actually, let's make this a little easier. So before we get into these other examples, we'll just come up with this state here, just so that way we have a place that we can, just call run with, do things with, and things like that. So we'll say that this is a state int of this, right? Okay, oops. Okay, so here we just do add nickel. We'll pretty much take everything but the run with here. Boop, pop. And then here we'll just do state dot execute with and get the same result. Right? Okay. That'll just make it a lot easier for us and make things, work easier, like look prettier. Anyway, so that executes us. We get the 15. We do all of that. And everyone's happy about that. Well, most people are. Okay, so like I was saying, this is ridiculous to have to, and it's not very flexible for us to have to take these normal JavaScript functions of adding 5 to a number and encoding it in this way. So luckily there are some helpers that come with this, right? So the first one that we'll look at here is this function called modify. And what modify does is it takes care of all this for us. Like it'll lift it into the unit, do the pair, do all of that stuff. So now all we really need to do is implement the JavaScript function here. So like for instance, we can just make this add, and let's see here. Add is of course going to take an integer and an integer, at least in our case, and return an integer, right? So we'll just make this curried add, and this becomes const add, and then we will take an x and we will take a y, and then we'll return x plus y, right? So now we have this add. So what we can do with this state instead, we'll get rid of all this. And here we're going to just pull modify off of it. Because it's a constructor function, whenever you pull just the monad in, like state in this case, you can just go ahead and destructure the construction functions, all these little helper functions. You can just destructure them off of it. So that's what I'm doing there. So now we're going to change this to, we still need to bring in nothing. And then from there, we want to just call modify. And actually, let's look at what modify does real quick. Let's actually look at modify. So we'll do const state, and we will do modify, and we'll do add 5, right? So now when we log this, we'll see that, and we'll do run with so we can see what's going on there. You'll see it gets us back exactly what we had before. But it's basically going to take a function and it's going to lift it into this state. Pretty much what we were doing up there with the state and making the state returning function. It's going to take care of all that for us. So it's going to take the function that we provided. It's going to grab the state off of the state. And then it's going to give us back a new state that is the result of passing the state into our function that we provide. So now we can take just our normal JavaScript functions like this add, and we don't have to do any of the encoding. We don't have to wrap it in a state that returns a pair and then worry about this, that, and the other. This will just handle it for us, right? And most of the time we really just care about the state, like I was saying before. There are times when we care about evaluation, but while we're building out our transitions, we really don't care so much about the evaluation of it or what's going on this A. So that's why it defaults to unit on the left side as for the state, right? Or I'm sorry, for the left side of the pair, but the right side of state. Okay, so basically, all we need to do now to get what we want is to throw our add 5 in there, which gives me, and since we apply this 5, it's going to return back another function that will take an integer, whatever that state is, and give us back an integer. And remember, I was saying we always want to keep this state the same. You never want to change the type of that state. If you do that, you're not going to have a good time, I promise. So don't ever change that. And you see when we're dealing with the state here, this add function is what actually deals with it. We keep the types the same. So be very, very careful to do that anytime that you're using this modify. Anything you pass to modify should be an endofunctor, or oh goodness gracious, an endomorphism, right? Like it should go from an A to an A. It always returns the same, right? Okay, so now, the thing that's really cool about this is because we have a lazy way of defining our definitions, we can just go ahead and say we wanted to, oh, I didn't show that worked. All I did was, so sorry about that. So this still works now. It's still the same thing. By throwing that add nickel in, we still get our 15. We transition from here to here, from here to here, and we transition from here to here, here to here, and then the last one brings us to there. So now, since we're all lazy and all we're doing is building states, I can base transitions on the composition of other transitions, right? So while we have this add nickel, I can go ahead and create an add dime. Since add nickel is defined, I can create an add dime here, and this is pretty neat, that instead of doing this modify or doing things like that, it actually comes through and we call add nickel, and we just do chain add nickel, right? So now we have this add dime that's built up from other transitions. We didn't have to do modify or do anything like that. We were able, and because we're chaining this in, we're not going to get some nested structure. It's going to be able to collapse and merge every single one of these state machines, or every single one of these state transitions, into one greater transition. Right? So it's the same composition that we're used to with when we compose functions. Pretty neat. So now, instead of doing this, we can we'll get rid of this person here, and we'll come here and do add dime. And really, it's just the same. It's just the same thing that we just put in there. Remember, we were doing add nickel, and look, we get back our 15. So let's move this back to evaluate with. Or execute with, right? So that gets us our 15. But we didn't really do that. As far as the transitions are concerned, we went from 0 to 5, and then we took dime. So we went 0 to 5, and then we took dime. But look, it got us right back to 15. Same way anyway. I hope this is making sense. Is all this making sense? I guess now's a good time to ask. Are there any questions? I'll wait for just a few minutes, let the thing catch up, and give you a chance to ask them. I don't see anyone typing. All right. Okay. If you guys have any questions, or if you people or guys or gals have any questions, just go ahead and throw them in the chat. I'll make sure to stop and answer them. You know, we're all kind of in this. but I don't get what the left side is for. The left side. Do you mean the A, Julio? Oh, the unit. Yeah. Okay, we'll get to that. We'll get to that. That's the part where we're a functor, right? Like that's where we're the functor on. It's the left side of this pair, but it's really the right side of the type. It's flipped in the pair for usage reasons and a couple other reasons. But it's to the left of the pair, but it's actually the far right of the type, right? Okay. All right. Okay, so now we go on, we have our add nickel, that gets us our add dime, but really I was just kind of showing off here. We're not going to do that. We'll just go ahead and just make these one-offs, right? There's no reason to, although we can build everything off of dime and then off of nickel and then off of nickel and dime, which is just built off nickel. It gets a little weird. So, well, it doesn't get weird. It's just there's no reason to do that fancy stuff. So we'll just do this, and then we do add 10. What is wrong here? So then we have modify, add 10. State chain must return another. Huh. Oh, wait. No. Oh. Duh. Sorry. So let's do this, and we'll do this, and that, and come over here, and 5A. There we go. Okay, so now we're back to our 15. Everything's going good there. So we can do this all over the place. So let's go ahead and add the quarter. So we can add a quarter here, quarter, and we'll do the same sort of thing, quarter. And here we'll just do add 25. So for people, this is what we call 25 pence or 25 cent piece, I guess. It's a quarter of a dollar. For our Canadian folks, we'll go ahead and we'll throw in a loonie. And of course, a loonie is 100. And we will, there we go. Now we got our loonie. So now we can do all of these different transitions. We could say take a chain in a quarter here, you know, and then that'll get us the 40. We could chain in a toonie or a loonie, not a toonie. We'll trade in a loonie, and then that gets us a 140 cents or 140 of those units. Right? So all we're doing is just building out these state transitions based on this, right? So no big whoop, no big deal. So what we want to do is, oh, I'm sorry. And we could see each one of these as someone, every time that they put in a nickel or put something in, we just compose this along, right? We just say, okay, they have... they added a quarter, right? So somehow, somewhere, it puts this in our little chain and says, hey, this is a transition. Now, the part that really matters is not really, to get to what you were asking about, Julio, is we care more about, at the end of all of this, we care if they have enough money to get their selection. And that's when we take evaluations of state. Right now, we're just executing state transitions. But there's another type of transition that isn't shown here, but it's pretty much an arrow that points right back to the state again. So it doesn't change the state, but it does change that A, or that the part that we've kept setting to unit, right? So at that point in time, we want to take and audit the state and then maybe compare it or do some sort of computation with the state at that current time. And when we do that, we call that evaluation, or we evaluate the state, right? So to evaluate the state, we can do, there's a couple ways to do that. But basically, we need a way to read from the state. So since reading from the state is an effect of this monad, we need to chain it in. So it needs to be chained in so we can actually realize the effect of the monad, or of the state. So to do that, what we're going to do is look at another attribute. So we have all of these, we had that modify. We have another one here called get, right? So that's here. It's also on the constructor, so we can pull it right off. We now have that get helper that we're going to bring in, and I'll show you what this does, right? So get's pretty interesting. Because it is a functor on the right, and that's where our calculations are, is where that A is, we need to take the state and move it over to the right. So, or to the right, depending, I don't know how the camera is. So we need this state to become, to give us back something that is this, right? So in this case, we have a integer, or we have a state of integer, but instead of the unit coming back, sorry about that, sore throat. That was really weird. We want to not return unit like we have been returning. We want to return an actual integer so we can do some sort of manipulation on it. And what we really want to do is take a function that takes an integer to a Boolean. And we want to say, I don't know, we'll call it CanVend or something along those lines. What's a good name for it? Hold on. We want to call it CanVend, I guess, or something like that, right? So let's see what that looks like. So we're going to, for now, get rid of this state here. And here we will, let's just see what get does, right? So if I just pull get, you'll notice I get the state back with execute. But let's just do run with, so we can see the pair. So notice how the state matches the argument, right, or the parameter of A. If we were to make this, 76, or actually I can't do 76 because that doesn't meet our alphabet. Not that we're checking for that, but we'll notice that it always matches it exactly. So what we really want to do is to be able to map over this, right, with the function that we define in JavaScript. So let's go 7G, and we'll call this CanVend. Okay, and we'll CanVend with, or we CanVend when a number is greater than or equal to 100. We'll say that it's $1 or whatever. So CanVend is going to be just a normal JavaScript function. CanVend is just a normal JavaScript function that goes from an integer to a Boolean, which is what we want. We want to turn our state from that's an integer, and we want to turn it into a Boolean. So now this is just your normal JavaScript function that we can then lift. And what's the best way to lift things? Is with a map function. So now we should be able to map any function that we create in JavaScript. We can bring it up and map it inside of the state monad. So here we'll just do CanVend. Now you'll notice on our A there, we get false because we can't vend it yet, right? We can't do that because it's not $1. But say that we end up at the point where we're doing our thing and we say have a $1.25 in there. Notice that it turns to true, right? So what's going on there is we take this, we can comment this out so you can kind of see. We take this using this get and we move it over into the A portion. So we're left with a state of SS. All right? So now we have that state there. Now we can map over it because it's on the Functor side of it. So now we call CanVend. We've lifted our CanVend function into the state monad. And it runs it over it, returning the result, which is now the result of the state. Does that make sense? Does that click? It's kind of neat, right? But some of the, there are other libraries out there that implement this state, and just something to be aware of. A lot of them will offer a getS function, which is basically a substitution. So you'll see a getS, and that basically will take a function that will be the endo functor that will substitute in the state. Well, typically it'll substitute in the state, or run a function over it and then put that onto the functor side. But with Crocs, the get function actually includes that. So if you call it with nothing, it's going to default to identity and just give you back the state. But we don't even need to do this map with Crocs. We can just do CanVend, and then it'll get us the same exact result, right? So now, since this is a transition, we need to get it into our flow. So we need this to act with this. But typically, when you're building out your state transitions, you don't want to evaluate. And that's why the modified pretty much always returns the unit, so to speak. Or not so to speak, but what it is. It always returns that unit because the unit is... because we don't really care about the value at that time. We really only care about the value a lot of times is on the edge of when we care to evaluate the state, right? And there's times where we don't even care to evaluate the state. We just want to use state no matter what. But that's a whole other topic for another time. So what we need is another transition that we can chain into our other transitions before we call run with. So let's go ahead and create one of those. So we're going to need another Kleiss Liss arrow for this, but we're going to call this evaluate, right? So we have these other transitions, which are our state transitions. But now let's do an evaluate transition. Evaluate. And evaluate is just going to pretty much take in nothing, just like the other ones, because it's all contained inside of the machine itself. We don't get a lot of input from the others, or from the outside. It's all contained. I forgot the name of this state machine, whenever all your inputs just on the state. If anyone knows what that is. It's not the mealy. The mealy, you can change it input. The more, maybe? I don't know. It's been a long time since I thought about state machines. So here we'll do evaluate. And with evaluate, we will do one of these. And here we want to take a state and return back an int of bool. Okay, and that's what evaluate does. So here all we do is just put in what we did before, except here we need to do one of these, and then we just do get, and we do CanVend. So now we lifted our JavaScript function into this, yeah, so now it'll just work with our bits. So instead of putting it into this state, we'll just go ahead and add it here. Okay? So we'll throw it in, and here we'll just do a quick little chain, and we'll call it evaluate. So now we're free to update our state transitions and everything like that. Let's go ahead and set this back to 0, and we see that it's false. So this is pretty much considered the edge whenever we want to do our evaluation and actually run it. This is where we would apply any evaluation at that point, right? So we're not really building up and sending something on the right side and composing these functions. We're mostly building the state into a certain state and then doing an evaluation at the end to see, maybe give some feedback in a type other than the state, right? It allows us to talk about information about the state in terms that aren't the state. That makes sense. I'm not very good at explaining that. Gosh, I don't even know why I do this stuff. All right, so let's go ahead and say someone puts another quarter in, and heck, puts another quarter in. So now we have 105, and you notice it went to true. So we've evaluated our state. Eventually we got to there. And we could build a whole other portion of this that took away nickels and took away stuff. So every time we deposit money to them after they select it, we take their dollar, move the state in this case 5 cents, and then call vend nickel or something like that, which then decreases the state. So we can have states that point back at other states too. So we can follow this either way. I'm not going to get into that because it's not really relevant to our discussion, but anything you can do with the finite state machine, you can do with this state monad for a deterministic finite state machine that only relies on state, whatever that is. When you need to rely on inputs, like if you can query your inputs at given times, that's not going to work for this. You'll need a different data type for that. But anyway, so what I'm going to do is in my model here for the code that we have for this, I'm going to go ahead and we'll create another one called Vending. And so that way if you're following along at home, vending.js, if you're following along at home, things like that, whenever you go and download this GitHub, you'll see that in there, right? Okay, so let's go ahead and move all of this stuff out and clean up our workbench here. We don't really care about the state or things like that. We'll let you set this up however you want. But these bits here will move into vending. All right, so what do we depend on? We depend on this, and we'll jump over here. Okay, so that was 45 minutes of utter bliss. So now that we have all that moved over, we'll do module just to make sure we have a good interface here. I'll let you export it however you want. So you guys can play with this however you want. Maybe I'll export all these and give an example of how to use it or something like that whenever I go to commit it. But that's going to be inside of Vending in model. So if you pull down the repo and all that, that's where it's going to live. All right, so we're 45 minutes into this. I want to do the rest of it, fixing up our actual bits here. All right. So we have this Rando file, and this Rando file isn't very good. And that's because we were operating under the assumption before, just like we're operating before, on that the state monad is a way to work on a mutable state between a family of functions. And that's not really the best, as we've seen with this code, that's not really the best way to think of it, right? Because you end up with a lot of this code. And obviously we see, like, we know that we don't need to do this map because here we're dealing with two different transitions, right? So we're actually doing a transition here, and then down here we're updating or doing an evaluation, and when we call Rando, right? And we're basically doing two things in here as evidenced by this. So we did see a little something last time when we put the arrow in. That part was pretty cool. Because it showed us, even though the implementation was horrible and it just added complexity and gave us nothing, one thing it did show is that we can divide these two different parts out, right? So there's a lot going on here, and a lot of things we can change. For instance, this def seed and all that. This all made sense when we were working under the assumption of the state machine modifies mutable data on a related family of functions, right? This made sense, even though it's really ugly. So what I'm hoping is, as you've looked over this code and been like, well, why am I even working with ADTs? This just added a whole mess of complexity to do what I could already do in JavaScript. Why am I even doing this? And that's because we weren't thinking about it properly. So let's go ahead and just rewrite this. And now, using what we know about a state being just a collection of transitions that work on a given state, I bet we can come up with some better ways to kind of clean this up. And pretty much all of this is going to go away. So I don't see any reason to keep it around. All right, so really all we really want from this is this PluckSeed. So let's go ahead and jump into our, we'll open that in a new tab. Let's jump into our workbench here. And with our workbench, let's bring over, what do we need to bring over? PluckSeed, okay? And we'll bring PluckSeed over. And I went ahead and left that because we need to see what dependencies we need to bring in. So it looks like we need this, and give that what I like to call a paste. And we'll jump over here and we'll grab the B combinator and throw that up here. That's basically just compose. If you're ever wondering, compose is named after the B combinator, which became the Bluebird combinator in the To Mock a Mockingbird book. Anyway, so now we have this. So now we have this function PluckSeed, and this will basically just pluck the seed off of it. But we'll notice that it is actually a JavaScript function. There's nothing about state. There's none of that here. It's just a JavaScript function, right? So we're pretty good there. Now let's go ahead, just to make this a little easier to work with. Let's add some initial state here. So we'll create something called InitialState. Okay, and this is our initial state. We're just going to name this game state. Okay, and just so you can see how this would work in the overall picture of things, we're going to do a const is equal to, and we'll have our deck of cards in here. Right now we'll just put it as an array. It doesn't really matter. And because we're using a pure random number generator, that's awesome. That's awesome, Julio. It's a good book. It's really good. It teaches you combinator logic, which is really interesting stuff. Lambda calcs and things like that. Super fun stuff to play with. So since we need to provide our initial seed, normally we would do something like this when we're working in our actual program. We would just say date.now, and that would get us the integer that is the date that will seed our stuff, and that way it appears random. But we don't want a random value. We want to have some consistency or consistency as we play with this. So we're just going to start it and seed it with the number of 23, right? So now we have this initial state, and we don't really have anything to run this with. We need to start bringing some stuff in, right? So let's, instead of thinking about this the way we were thinking about it before, let's go ahead and set this up as transitions, right? So instead of having this Rando function that is one imperative transition, let's break this up into two transitions, right? So we have something here that's like NewSeed, right? So let's copy that over, and we'll just put this in here for now. And let's make a function, just a normal JavaScript function, that encapsulates this, or does this, right? So we're going to call this NewSeed. Any comments? We all good? All right, we're going to call this NewSeed. And NewSeed's basically, since this is working on a the state, or well, since this is working on anyway, it's basically going to be an endo function, right? So we'll have NewSeed, and NewSeed is going to take an int and give us back an int. And all it's going to do is generate a new seed value based on the seed. It's basically our calculation that we have. So here, we could just do this, right? Do some of this, and then replace this with seed. Boom. And we'll place this here. Oops. We'll place that there. So now we have NewSeed. And that's just a JavaScript function, so we can go here and do log, and we'll do NewSeed, and we'll pass in whatever we were going to seed it with, and we see we get back this number. What is the dit operator? What operator? That operator in Haskell is for arrows, but I don't see that here. Oh, this operator. Yes, I'm so sorry. I'm so sorry. That is the binary or bitwise shift right. Oh, and that's wrong too. This should be 16, not 15. Oh, I wonder how that happened. Okay, that's wrong. But yeah, that is what's called the bitwise right shift zero fill. So it basically zero fills the sign. You should look it up. It's very interesting. But we're doing that to limit. It's just if you're curious, I think it was 2 episodes ago, we actually went deep and talked about this whole thing. So if you check out the other one, I think it's ADTs 2, working with ADTs 2, we actually did a deep dive and explained this whole thing. So check that out. So now we have this NewSeed, and as we see, when we pass it 23, that calculates our NewSeed. So that's pretty good. Now we need to move the other one out, this calculation of float, or this value, right? So let's go ahead and we'll bring this out. And this doesn't need to be a float, because all this is doing is taking whatever our seed value is, and it's doing a little bit of funny math to get us a number from 0 to 1. That's all this is doing, right? So what we'll do is we'll create something called calc value, I guess. Calc value. And calc value is going to take the integer that is our seed. And again, this is just a JavaScript function. We're not doing anything with the states yet. Not doing anything with them, right? So we do this, we do that. We could even bring in compose. Anyway, we do this, we do that, and then we want to take this value and then give back a float. But it's a float between 0 and 1. Anyway. So to do this, we'll basically just do the same thing that we did up here with this function, because it's pretty much the same thing. We'll just do calc value, and then we'll take this and we'll rename this to seed, right? And we will do this, and that is our function. Okay, so now we can calculate that value. So say we want to, we will do a composition here, and we'll say calculate value, and we'll do this. This will pass in 23, which will take that and run it through this function. It's just your basic composition. And then we see we get back a 0 or a number from 0 to 1. And in this case, it's .81818. We would get that back every single time, right? And notice we haven't done anything with state. We were able to represent this in JavaScript. So now let's actually start lifting this into the state. And when we start dealing with that, basically what I'm saying with this is these functions can vary independently as long as their types stay the same. As long as this NewSeed always takes an integer, returns an integer, and calc value always takes an integer and returns a float, these can change underneath the state monad, and it doesn't matter, right? Because we're going to lift these in there. And as long as their types are the same, we're good, which is beautiful. I forgot that's called the replacement principle or substitution. I don't know. Anyway, we can replace any of these, basically. But we're going to need some helpers to do this, right? So if you look over here, how we were doing it before, and I still think this is an amazing way to do it. So basically, that PluckSeed is a way to pluck the seed, but we also need a way to do this assign, right? See this modify assign? All we're really doing is, it would be nice, since we always work with this seed operator, to have this as a function called putSeed or something like that, right? Because all this is, since it is a modify, is a transition, right? Does that make sense? So let's look at a couple helpers here, or so let's make a couple helpers, I should say. Now we are done with the JavaScript portion. These are the functions that we need to generate our algorithm, this NewSeed, calc value, and PluckSeed. These are the things that we need to actually work with these. That's the JavaScript type stuff, right? So let's go ahead and make a getSeed. And this will just be a function that gets our seed, right? So we already have the function to pluck it, right? We're using this our prop inside of Crocs actually returns a maybe. So we need a way to, what this does is it returns the maybe, pulls the seed off of that. If we don't have that maybe at that time, like say we don't have that value of seed, it's going to default to whatever we passed to the first parameter and give us that back. So we're always guaranteed something for this, is basically what that PluckSeed does. It looks a little silly, but, and that B, of course, is the B combinator or the Bluebird combinator, which is compose. So all we need to do for this is we'll do, we should do the right functions here. And actually I should put what the type is, but we'll do that in a second. So this is basically get, and have I talked about? No, I haven't. We need to actually, so remember before where we were, we'll bring this stuff in. So remember before, when we were going over the vending machines and things like that, we use get to do a calculation, right? So we're actually performing a calculation here when we get the seed. We want to get that value and move it over so it could be worked on. So we are plucking that off of it and throwing it onto the functor side. So then that way we can do calculations on what the current seed is. Because what we want to, and that's basically, this is a helper that will wrap get and get us just the seed off of that, right? So now we can do that with get with PluckSeed, and let's see what that looks like, right? So let's do get seed, and get seed doesn't take anything because we pull that off of the state. We're not modifying anything, we're not doing whatever, we're just pulling the seed off of the state. So if we run that, we see, or if we throw that, we see it gets us back a state that's wrapping our state function. And then from there, we want to look at, because it's on the functor side, we want to use eval with. And if we look, if we put in a seed, oh, and actually, we need to, because remember, PluckSeed is a binary function, and this should take game state. Okay. So PluckSeed, yeah, takes some game state or whatever and then plucks that off of it. We need to give it a reasonable default. So what we'll do is just give it a reasonable default of 0. So that way if we didn't provide this, right, and we just called eval with, and we put in, I don't know, 100, right? We would be broken. Why are we broken? Hold on 1 second. Oh, wait, maybe not. Stand by. PluckSeed takes a def and then options the def. Am I missing something here? What am I missing? Oh, I know what the problem is. No? Boy, do I love live coding. All right, let's see what's going on here. So I call PluckSeed. Oh, okay. We have to eval with something. That's right. I actually have a, never mind. I have a bug in on Crocs for that. It's the problem with this prop function right here. I just filed a bug for that. So anyway, if you notice, if we don't provide seed on our object, like say we're going to do initial state, initial. Okay, so if we do our initial state, see how it uses the 23, but if we take that away, it defaults to our 100, but we can actually make that 0 here, right? So that would probably be a little bit better. So here we'll just put seed back in and we'll do 23, and we see that we get back our 23. So this get seed actually moved, since we're using eval with, moved that over into the functor side of our bits. Okay, so now we have getSeed. Let's put a type on here real quick just so we have a little bit of completeness. And this is going to move, of course, from unit to a state of game state. And integer? Yes, because they're always ints. And let's move this to ints so we have a little bit of continuity here. I know the proper name is integer, but int is just on this big font. It looks a little nicer, right? So now we have our getSeed. That actually pulls the seed off of there. It's just a little helper function. It doesn't really transition state or do anything like that. Well, I mean, it does, but we're not really using it in the meat of our program. We're just using this as a simple way to pull state off. Now we also need a way to put state up. So let's go ahead and make a little function here that we will call putState. Okay, so we'll D2S and, putSeed, and we'll do that. So what this does is, because we don't really care about the calculation of it, we don't want to do anything with that, this is going to do our normal unit that we send, right? So what we'll do with this is just become basically what we're doing here. See how we do this modify, assign, and then bring seed in? Actually, we don't need any of that. So let's go ahead and bring assign in. So now we have assign. That's basically all we want to do here is just take this seed. So for putSeed, we are going to take a value, and we need to take an integer, right? Because this is something that gets chained in. We want to take our integer. Oops. We want to take our seed. And then here, we're just going to do a modify. And we don't want to overwrite. We don't want to change what the actual entire state is. The only thing we want to work on is just the seed. So we can do that with crocs assign, and we'll assign it with seed. Okay? And we will call this putSeed. Delete to S. Okay? So now we have this real, let's do that. That. So now we have this really neat way of putSeed. And say we want to change the seed to 54. Remember how it was 23? So now we'll just do a val width, except we don't really want to do a val since we're updating the state. Well, we'll see what a val width is just to make sure. So see how we get our unit there, just like we're saying that we're going to have our unit. It's returning our unit. And then after that, if we do delete to dubs and execute state to get back the actual state, we see that it updated that state to be 54. So now we have a function that whatever we pass the seed, it's going to update the state, right? And these are all just transitions. All we're doing is transitions, just like we were doing in this real simple machine. We're just transitioning stuff based on that. So now that we have all of the functions that we need to, or all the helpers and things like that, we really only need two transitions here, right? So there's two parts to this. We need to generate the seed, then we need to take that seed and generate a value, and then return that new game state and the integer, right? And so that way we can get the randos. So let's go ahead and delete this, because all of this is pretty much just going away. We don't need any of this anymore. We don't need assign, we don't need that. Pull random, we don't even need. We don't need any of this. None of it at all. It's all going to go away and replaced by this. All right, so let's create our first one, the first flow, and that was generating the seed. So we'll do const gen seed. Okay, and then gen seed is a when we generate the seed, we don't care about the unit, so to speak. We just want to update the state or the seed in the state, right? That's all we want to do. It just does one thing. It changes the seed. So here we're going to have our gen seed. And GenSeed is going to take what I like to call a basically it's nothing because it all depends on the current state. We're not taking any outside input or anything like that. And that's going to return us a state that is the game state and unit, just like we see with this put. So chances are we're going to be using this put seed somewhere. So we'll go ahead and make this equal. There's our little unit. And we need to get the seed so we can work on it, right? Because our function to generate the seed needs this seed. So for us to actually put that in and do all this, we need to call getSeed. Now another way we could do this is make something called substitute seed, but we're not going to get into that. We'll probably refactor this here in a little bit, right? So the first thing we need to do is, and let's just do GenSeed here. Okay, and GenSeed takes nothing. We notice we get our 23 and it moves it there. Let's just do eval with. Oops. Okay. So we see that it gets our 23. Now we need to map, right? So now that we have this over on the right side on our evaluated side, oops, we need to go in and then map our function. So we need to lift our NewSeed function from JavaScript into this state monad. So we'll do that with NewSeed. Okay? And we see that over there on the right side, we have a brand new seed that was generated from that. And all we had to do was lift this JavaScript function in there. I mean, we could change this too, and now we can make this always return 4 if we want to, right? Like, it doesn't matter as long as it matches the type. So right now we've lifted this NewSeed function, and it has turned, since we're doing eval, it has turned the right side into the NewSeed, but at this point it has not touched the state. So if we look, the actual state itself is still a seed of 23. So now that we have it, and we have it inside of our functor portion, we need to write back into the state. So again, it's just a transformation, or it's just a transition. So what we're going to do is call chain. Now we can call chain on it. And I mean, it's pretty much the same thing as we were doing before. And then we'll just do put seed. And now we notice that our seed has been updated. So now, by calling GenSeed, we started with our initial state, and now our seed has been updated. Which means now that we have an updated seed, we can evaluate it because our state has been updated. So let's go ahead and add that right now. So we will call this evaluate, right? Just like we did on the other machine, or on the vending machine. We'll call evaluate, and then evaluate is going to go from a unit, and let's just look at what this is, right? So this is going to be what we're going to pull our numbers from. This is what we're going to pull all of our random numbers from, our numbers from 0 to 1. It's basically this calculation here. So we'll do evaluate, and then this is going to go unit to a state of game state, just like all the other ones, right? Except here we're going to be a float on our right side. This is going to be that actual float that we're going to generate from calc value, right? Does that make sense? We all good? Okay, and I'll stop at the end of this for some additional questions or anything. I see people dropping out. I don't know if it's from boredom or if they're just lost or things like that, but feel free to ask questions or anything if you find yourself lost. Like, it's fine. It's totally fine. So then we can do our evaluate, and what evaluate does is it gets a seed, and from that get seed, we then call map and calculate float. Right? Or, yeah, calculate value. So now when we're done doing our little bits, we can come here and we can do chain, and we can do evaluate. Okay? And then instead of doing our execute with, instead of doing our execute with, we can do eval with. And we see that we get our number. And the part that's really cool about this is basically what that other function of pull random becomes. So now that we have these two transitions, we can encapsulate them in the one function that we expose that'll get us this answer. But now we're free to move things around and take stuff from JavaScript and bring it in to our little space or our little context that we created. So now we'll just create our pull random, right? And pull random, and we're going to say that pull random takes a basically nothing, right? Hold on real quick. So it basically, just like all the other ones, it's all dependent on its current state. It really doesn't do much with the input from the outside world other than its initial state that comes in. So with pull random, that basically moves from that to a state of game state and float. So it's basically the result of evaluate, which probably means we're going to be doing the same sort of stuff. Or basically probably returning with that, right? So here we do our little gen seed. And, oh, sorry. We need to set that up. Oh, and if you guys are curious about how I'm deciding how to do this indentation. Basically, if I'm going to use this fluent style on something, I typically will put the parameters on the same line as this definition. But if I'm going to define it in a way like this, where it's just functions on functions in composition, I tend to put those on that line. So there is rhyme or reason to it. Rhyme and reason, I guess. All right, so what we want to do with this is, now that we have the way to generate seed, we want to mix these two transitions together. So we'll do that by chaining in evaluate. Okay? And then now when we come down here, all we need to do is just call pull random. Okay, with nothing. See how we get the same value? But the thing that's really neat about this is we now have a chainable function that can be chained. So if we want to pull another random value, say we want to pull another one, it doesn't matter. It all carries the same state, and we get exactly the same thing that we had before. Now, we did have to sacrifice, like, this looks a little bigger than the other one, and a lot of it has to do with you know, our new lines, and we're putting other functions in there, and then there's spaces between the functions. So and maybe it does add 1 or 2 or maybe 4 or 5 more extra lines of code. But it gives us something that actually fits. We didn't have to bring in another monad like arrow or things like that to recompose and deal with that imperative style. We were able to actually use the type that we decided to use for the entire game and think of it in a different way that allows us to just come up with these simple transitions and helpers with them. And as you see, like, you may not see the value of it now, but as we get along and we start implementing the game and actually getting this to work with the deck of cards and things like that, then you'll really start to see the value, as we're going to have to change parts of these and extend parts of these. It takes a little bit to think about these types, but it can add a lot of flexibility to you. And notice we're no longer thinking in step by step like we were before. In the old version, we had that Rando function that had to be all set up and put together and all of that, if you look back and see what it was. And actually, I wonder, right? So this is what we had before. And notice we just had these big blocks of code, of nasty imperative code that, I don't know, none of this really looks that functional. And then we had to do all this setup and, like, do this get to this chain and do all of this stuff. Something obviously was wrong with this code. And what it was we had the wrong intuition, in my opinion, for how to use this monad. So let's go ahead and we'll wrap this up by me moving this stuff because we're going to move all of this just right back. We're going to move it right back into here and replace all of this, right? Because this is trash, right? So we did add, you know, a good amount of lines of codes to this, but it's much cleaner, and it can be separated easier, and each one signifies an actual helper or a helper for doing transitions or an actual transition on the state. So this more matches like how to use a state monad, right? Hopefully this makes sense. I'm hoping. So now when we go back here, we should be able to take all of this out. So we can take this out. We want to keep that initial state. We want to keep that. Okay. So now if we just come down here and we do pull random, and we'll pull that off of require rando or model rando, we should get the exact same result. And we do. And then now, if you look, if we do our little date.now, which is what we would do normally at the edge of our program, we get a different random number every single time. Sweet. So, I hope this made sense. It's really all I got for you. Next time what we're going to do is, now that we have this flat structure and this game state kind of defined, we're going to go through and we're going to get the deck to actually work with this state. So it'll be able to pull numbers and do things off of that, right? So, yeah. So next Saturday at 3:30 Pacific time, whatever. Join me again. We'll get over this, or we'll get through the hump of updating the deck. And as soon as we have the deck updated, the next episode after that, that's when we're going to define the quick little business rules of like when to show a card, when to do that, and capture as much as we can in the model. And then after that one, we're actually going to move this into a front-end app that's using HyperApp. So, oh, and also one of the things you may have noticed is another way to think of this. Think of Redux, right? Like, what if reducers weren't reducers? What if reducers were just simple state transitions? This is pretty much that model, exactly the same. So this state monad, even if you're using React or HyperApp or things like that, all it really is just a state monad. That's it. Like, you could make this yourself in just a couple lines of code in a state monad. Like, you could have your own Redux that you don't have to do function composition. You could actually build out simple functions that are just a state transition. So anyway, it's just something to think about. This stuff's pretty cool. So, well, for the 5 of you that are left or actually watching, do you guys have any questions or anything? Feel free to ask. Or if you want, whenever this becomes a video, throw comments in there. I try to respond. I don't know about time travel. I don't have enough bow ties to actually figure that out. What's his name? Brian McKenna. Oh, and by the way, quick correction. Last time I did this, I called Brian McKenna Puffin Fish or whatever. It's Puffin Fresh. If you don't know who he is, he was the person. Oh, time travel. Yeah, you can, but you just have to put the listener in there, right? You can use a writer, and a writer would keep track of each of your state transitions. And actually, you know what, Julio? Maybe after I finish this up, I'll show you how to do that. So yeah, that's good. You can do it, but you can't do it out of the box. You need to add another type to it. But that's fine. That's fine. That type, and you wouldn't add it to here. You would add that at the edge, right? Like, the user shouldn't know about that it needs to do these sort of things. Like, if you were to implement a Redux with this, they shouldn't need to know about the fact that you're using a state. But yeah. So that's all I got. If you guys have any questions, no one seems to be hitting it up. So go ahead and leave comments down in the video. If you have no idea what I'm talking about and you feel like sitting through some more of these silly little things, I have a whole series of these. And I do put the code on GitHub. And also, one thing I want to note now, I first thought the unit at the left was for that. No, it wasn't for that. Yeah, I got you. I got you. So one of the reasons I'm doing this is I have a site that I've been working on is coming to a close now that football season's starting, so I won't have to deal with that. I'll have my free time again, so I'm going to go back to making egghead lessons. So what I'm doing with these is I'm trying to explain, like with these live codes, I'm trying to figure out the best way to explain these in 5 to 7 minutes and like how they break down, where I ramble too much, things like that. And I want to start getting back and putting these back on Egghead. So you might see coming up soon, after they go through approvals and things like that, you might start seeing some of this same data, but in a more abridged version, or not abridged, but more focused, and explaining each one of these concepts, not each one of these, but the certain discrete portions of them in 5 to 7 minute chunks, right? So a lot of this, it's really good. I feel bad. They gave me this opportunity to make these videos, and I'm like, oh yeah, I'll be happy to, and then all kinds of weird stuff happened. I kind of had to put that on hold. But soon I'll be getting back into the egghead thing and getting more functional stuff out there. Also, shout out to well, no shout outs. I'm not good at shout outs. So again, thanks for all your time. If you guys got anything, you can follow me on Twitter. I'm EvilSoft on Twitter, and the EvilSoft here, obviously. I usually tweet out the things that I'm doing. So if you want to follow me on Twitter, you might catch an impromptu live code or a video or things like that. So anyway, have a good one. It's been a real pleasure, and I will see you guys and gals next week.